out there in YouTube land. This is Barry, Mike, and Andy from YouTube Model Builders Hangouts, the Barry and Mike MRR Tech Show. We are live in living color. Tonight we'll be discussing the uses of the PICAXE chip for making simple model railroad electronics projects. Well, it's a little basic programming and such, and it's a little electronic knowledge, but it's not that hard. There's a lot of programs out there for you to use that are already written. So we'll run through some samples. Let me bring up the next slide here. So do not forget, YouTube Model Builders is your source for free model railroad information. We have our free online e-magazine, which is due to come out again next month. We have our live chat presentation hangouts, which you are on here. And join us live every month on the YouTube Model Builders live show. It was just this past Saturday, where we toured the Pacific North Central layout with Troy and Bill and myself. So I hope everybody enjoyed that show. And tonight we're going to go down a deep rabbit hole in electronics here. Move this out of the way here so I can see what I'm doing. Alright, so what we have here is the simple proto board, a programmer, and some LEDs hooked to it. I preloaded a simple crossing flasher circuit. So let's go through some of the hardware that's necessary here. And then we'll talk about where to get them from. You see here is a little PICAXE programmer board. It's got 3 wires soldered to the back, because this was modified. There's a little servo cable that plugs onto the board, and then you plug the USB connector here, hook into your computer, and you use the PICAXE workshop programming tools. If you have an unmodified board, you can use one of these USB cables, which has a 3-prong audio jack for doing the same programming. Over here, we have a PICAXE prototype board, which has outputs tied to it for testing, your programming input, power, regulation, and everything. So that's a great thing for programming and prototyping your circuits. And then you can use a little board like this proto board to build projects with. And you mount your programming port, a couple components, power supply, and your chip socket. And then you're ready to put whatever you need on here with connectors for LEDs, servos, etc. to use this in your project. And I got some of this stuff from Miles Hale to demonstrate with tonight. Some of this stuff is bought through SparkFun. We can see we have these little pre-wired LED cables for testing, and you notice validating our circuits with. They're very handy because you can, have different colors we want to, pop them out, pop them into your circuits for testing purposes. And some great ideas you can get for this stuff comes from a website guy named Dave Bodner at what is it? Let me pull it out. I think it's trainelectronics.com. Yep, trainelectronics.com. So I've taken his clinic before and learned a lot about this from him. So this right here, this is from SparkFun. This is one of the unmodified programmers right here. So we have the audio jack plug and the USB plug on the other end for programming this with. So that's actually a handy little board to have. Like, is there any other companies that make PICAXE programmers out there? Mikey. Oh, I hope I didn't get frozen up here.
No, you're still good.
I think Mike's not hearing us right. Okay, so
that's good.
Hey, you're breaking up, Mikey.
Oh, wow. All right, hang on a second. Let me play with this.
Yeah. So this is the unconnected board. Like I said, this is how you can buy it. Your chip goes here. And you have your power connection, power regulation, and all your connectors. And these potentiometers are tied in for some of the circuits to adjust rates of control and everything. So, but yeah, all this stuff came from SparkFun. And there's different type of chips. Besides the PICAXE, there's also the PIC chip, which is a more powerful processor. But this is what's called the 08M2 chip here. There's 3 chips here. And you just pop them into the socket on the board to program them. This is a little tube. This is a PIC chip. It's got, like I said, it's got a more processor, more memory capabilities. And in the board here, this is an 08M2 and these small ones here. And this board is a 14M2. It just has more outputs. You can see this has sockets for 6 LED outputs.
So Barry, so there's numerous of these PIC chips that meet the PIC standard, and they're cross-compatible with the various boards you can put them in. Is that?
Yes. Yes. So you can. The circuit's designed to take multiple type of chips, and then when you program it, you select the type of chip that you have. So it makes it a lot simpler. Yeah. Pop the camera back in here for a while. Okay, here we go. So first of all, let's do a little history here. So PICAXE chip was developed in Great Britain, originally designed for schools to use in teaching. So because it's handy, it's inexpensive, it's real easy to use in education. As to capabilities, it has all the capabilities of a computer. So it has input circuits, output, it has memory to store the program you load, and it has control features. So it can not only drive a logic output to turn an LED on and off, but it also you can set one of the outputs, say, give it a command to say use pulse width modulation to drive a servo. So some of its limitations are that the input voltage to it must be regulated. So that's why on here you see this circuit right here. This is the LM7805 5-volt regulator. That and a couple of discrete components, and you got a voltage regulation circuit. It does require a computer for you to program it, and you just type the code into the console of the program, which I'll show you. And that way, it then has a USB connection, which is translated into a serial port on the board and uploads it. And one thing, it does expect you to properly code the software. It doesn't really forgive if you make errors in the program. It just may not upload, or it may not work at all. So as to the hardware that you need to use a PICAXE, you need obviously the circuit for the board. You need the PICAXE chip itself. The programming software is free from PICAXE.com. It's PICAXE.com. And you need one of these little USB programmers I showed you. And you need a Windows computer, Mac, or even Linux computer, so it pretty much can be programmed from any kind of computing system that you have. What was that? So as for power, it can take anywhere from 3 to 5 volts from either a battery or a plug-in AC adapter. The board I have here has a little 2-pin connector, and it's plugged into a 5-volt wall wart, so, which is fine for programming it. If you want to control it from a battery source in a movable, like a portable object, it's certainly possible to do that. So what are some of the things that can be used in your model railroading environment? The one, obviously, the sample I showed here has LEDs on it, but you can use light bulbs too, as long as you don't exceed the current capacity of the chip you've chosen. You can control the speed and rotation of a motor, so that means animations are limited only by what you can imagine doing. You can use servos with it. Like I said, you can program the output to be a pulse width modulated output, so you can drive turnouts, animations, signals with it. You can control MP3 boards with it, so you can control sounds from external boards, and you can even load software where you can operate a train, operate your switches, signals, etc. So it's a pretty versatile thing, and I'm going to investigate this into working on some building lighting, and maybe even see if there's a possibility of programming it for signal control, like it says in the presentation I read. So, like I said, there's many types of PICAXE chips available. The one here on this board is called a 14M2, and the components you would need to complete a basic circuit are 2 resistors, a voltage regulator, a plug to plug your programming into, and the power supply, and your computer, and one of those little USB to 3-pin programmer boards. So it makes it nice and easy to do. I said you get your PICAXE software from PICAXE.com, which includes an editor, a programming simulator, and programming software, which is really nice because you can actually write a piece of code and then run a simulation to see if it does what you want it to do to the output of the chip. So let me share that. Oh my God. Everybody can do this. Okay, so what you're looking at here is the PICAXE workshop, or PICAXE editor. So I have 3 simple programs on the screen here right now. So here you can go and create a new file, and then we'll put a new tab on here where you can start coding in. Under the settings in the Workspace Explorer, you select your chip type. As you can see, here's the different chip types you can use. So we're using the simple 14M2 right now. And then you pick which COM port the USB program is assigned to. In this case, COM 8. And then for simulation, you tell it what chip you're using. So if I want to go and test out this program right here, this is what's loaded on the chip right now. So we'll go to simulate and we'll do a run. Yeah, and there you go. You see it's actually flashing 2 different LEDs now. So that all that circuit's doing, it starts up, turns on the LED, and then toggles back and forth in a continuous loop. That's all it does. And this is simple to show that, yes, I can flash the LEDs. There's ways to put trigger controls in here so that it'll turn on and turn off. So it's nice and easy to create a crossing flasher. And all the work is done by the software. The hardware you need is the trigger on the start and stop that you assign to pins, and the output goes to LEDs, and it's that simple. Now here, this is another program here, so we'll go back to this one. Stop. And we'll go to this one here, and I haven't tried to run this yet. I just pasted it in here tonight. So that there, it's flashing 2 LEDs back and forth. It's very, very similar to the other ones. And then we have, stop that one. This is a new one here. This is a lighthouse one. It uses several LEDs to mimic a lighthouse, so it has a certain flash profile. So I'm going to see what we got to do here to go ahead and just make it like that. It's the same one. Yes. That's let's take this line out. Right. Now it's just flashing the one LED. That's all it's doing. It's just toggling back and forth. And then I can just stop it. Enter that. Paste it back in. Go over here. And we'll steal that back. Copy. Paste it in. Run. And there you go. Now it's flashing the 2 pins again. So it's, as you can see, it's fairly simple. It's not complicated programming coding that you need to do this. The manual is built into, a data file that comes with the program, so it's fairly simple for you to read.
Have you took a look at this Chrome extension that the Chrome app that runs underneath it? Well, like here, I'll show you on screen. This one, if you've looked at this extension, you could do it in code, but you could do it in these little blocks where you just grab the block and say.
I was going to get to that next. That actually is what's called Blockly. That's included in this version of the programmer. So if I go back, I'll go back and.
Right, and the code that you're writing is more readable than Arduino, and Arduino is not hard for non-programmers to learn. It was actually designed for grade school students in Britain to be able to learn the essence of programming. So, any model railroader with a little bit of ambition could probably learn that code. But this block drawing, where you just grab blocks and drag them around, if you have an idea that you want to go from here to here, you don't know anything about programming. That's what I think makes this so accessible to so many people. Forget computer knowledge. All you have to do is drag this block to here, and then solder a couple wires, and it works.
Let me launch my okay, there you go, and launch my Blockly editor.
Dwight's asking, while you're talking about that in the Q&As, asking about the practical application for this as opposed to JMRI or a normal DCC system. And the one thing I would suggest, and you should chime in and see if your opinion matches mine, Barry, but is to treat it as an additive thing. There's a lot of things that JMRI is just too heavy for, or too complicated, or not suitable. Like building lighting. Doing that with JMRI is possible, sure. It's way overcomplicated to do it that way, and you never would. But with the PICAXE being so simple to do building lighting, why add all that complexity that's unnecessary when all you need is, when this happens, do this, or at this time, do this.
Right, and this also has applications for people who don't want to use DC, who are using just a DC layout, or people like Lino or American Flyer. You don't need to have DCC to run this. Like I said, it's usable to create, say, a signal system that's basic and simple. You could use it to create your grade crossing flashers. There's really no need to involve DCC and JMRI to drive a grade crossing flasher. It should be a standalone circuit with a few parts, and at one programmer you can program a fleet of grade crossing flashers and make them for a few bucks a piece instead of paying $25, $30 for a board for every turn, every grade crossing. So it's a lot more, I would say, cost effective. And if you're a little bit electronically inclined, you can do it. It's not that difficult to learn. The circuits are real simple to build. Like I said, it's a handful of components. I mean, they make these proto boards you can buy. You can get them at Radio Shack or SparkFun or something, and you literally just press the pins of the components into the board, and it makes the connections. Now we can build a circuit, and if it doesn't work, it doesn't work. And you haven't soldered the board to it, and you just got something there. Yeah, so there's boards that have solders like that, with solder rows. That's like the one I was showing earlier. It's a proto board. They also have the white plastic ones with all the pin rows. Whoops. So
Right, and the proto board is so valuable, especially since it's whatever 12 pounds would be in U.S. So
yeah,
16 or 18 bucks. Uh, it allows you to really quickly test what you want. You
yeah,
only need one of these. When it comes time to actually do the work, when you're committed to it, just take what you've tested on the proto board and hard solder it to your device and shove it in the in the basement of a little building and go on about your life. But this gives you a great way to test a stack of LEDs and see if you're going to get the results you expect.
yes, exactly, yeah. Yeah, see, Spark Fun calls they're called breadboards. Let's see.
Right, like the Proto Shield for Arduino, I've got a few of those. And they just make it so easy. And I've got one of those that has the breadboard on it, and I would
Yeah.
say that's a must-have.
Oh yeah. Let me bring it up and show you on the screen here what it is. Okay. Yeah. So that's called it's just a breadboard. Literally each row, well, between these two lines here and here, each row of pins is connected. So these are connected together. These are connected together. It's designed so you put the chip here, then you have like all these connections on the outside to connect parts to. Now you can jumper from say here over to here and then put more parts in. And then on each side you have one row connected this way and same here and same over here. These are used for power. So you plug your plus and minus in there or there, and then wherever you need the power supply, you just run a wire over to one of these horizontal lines here and plug your part in. So like you could take a lead of a resistor, lead of a transistor, and just plug it right in one of these holes, and it makes a connection to every other pin on that row or that row. So you can build your whole circuit, and then if it works, you can get a piece of board like Andy showed. They make boards like that that just have copper pads on them, and you solder the wires together, or you design a little circuit board. Um, SparkFun has a thing called Design PCB, which is free. Uh, it actually includes circuit board layout and schematic layout software. So it's nice and easy to use. So let's see what else. Mikey sounds like he's having technical difficulties. So we got White's question here. See what else we got in the way of questions. Gotta love Curtis. So I mean, there's a ton of applications you can use. Dave Bodner's TrainElectronics.com has got a ton of different programs and circuits on there, and sometimes the programs are written to a specific PICAXE chip. But let me see what
You see, a lot of people think that they have to, because of these electronics, that in this traditional sense, that if you buy a capacitor and a transistor and a pack of resistors, that you've got to figure it all out, write it all from scratch, and you can. It's entirely
you can,
possible
yeah.
to do that. But there's a tremendous trove of already written applications for this on the net, like this little DCC++ that I built out of Arduino.
Yeah.
I didn't have to write that code. I just plugged Arduino up and pushed the code to it. And
yeah, there's a DCC function library software that you can load into Arduino and use it to make a DCC decoder out of too. Dr. Jeffrey Bunz on Model Railroad Hobbyist did a whole series on it.
Right.
For $5, you can build a 17-function DCC decoder.
Yep.
Here you can see I have the crossing flasher running here. Now, there's ways to program this to control how fast the LED goes on and off, so you can simulate the flare up and go back down. Did you ever notice that a crossing flasher comes on quickly and fades out when it powers down? So you can simulate that by writing the proper code and for the chip and then uploading to the chip.
And that subtle effect of that light, of that bulb on the prototype fading out, basically, a lot of the models, a lot of the videos I see on YouTube of these crossing flashers look fake to me. And until you just mentioned that, I just realized why they look wrong.
Yeah, because I just last week when I was over the weekend when me and Mike were out with our club out in Lancaster. We obviously we were near the Strasburg Railroad, so I was checking out some of the crossings as I was driving by and shooting some video. And yeah, I noticed that's how it works. And you'll notice just like with a lighthouse, as the lamp is rotating, you'll see it dim, bright, dim as the lamp swings by.
Right.
So you can simulate that by using different program pieces in your code.
That seems a whole lot easier than trying to put a bulb on a motor. So
yeah, exactly, yeah. Let me start something.
And it's not that you can't buy most of this stuff. You could go buy a Circuitron crossing flasher as a $30 or $40 circuit,
right?
Or you can build it for $3. So
yeah, I mean that's the thing here. This is not so much about you need this instead of something else. This is a way for the people who are into electronics to build this stuff dirt cheaply.
Well, some of it, like a crossing flasher, sure, there's plenty of people, Circuitron and some of the other Tomair, etc., that make the crossing flasher circuits. Or like the Lighthouse circuit, you can buy that. I've seen one recently for $70. You could build that for $5.
Yeah.
So not only is it a cost savings, but look at the value you get in the learning experience of doing it that way, number one. And then what happens when you want to do something that you can't buy?
Right. You're absolutely right. Yeah.
And you don't have to invent this. You don't have to invent the way to do it. I think the community behind this product is the most valuable thing about the product. Somebody has already figured out how to do what you want.
Yep. Let's see this code. Yeah, this is just something fairly new that I'm getting to learn. It looks like it could have some interesting possibilities. Like I said, I want to play around with what features I can use with it to, try for lighting effects in buildings. Similar to the whole man Mike was promoting with his light kit design. And I think he was using the PIC chip, which I may end up gravitating that way because the PIC chip has got a lot more capabilities. But you can get into where you can do very complex programming because this is a form of basic language. PIC chip can actually use like C++. So.
But that comes with, capability. More capability comes with more complexity, often more cost.
Right.
It's one thing to expect a model railroader to be able to download something and do some little block drawing stuff here. Guys that are not into electronics but just want to get something done.
Right.
But with the PICAXE, sure, it's not as capable as some of the alternatives. But you don't have to learn C++. You're not going to have to go back to college for a year to put a crossing flasher on your layout.
Yeah, you're absolutely right.
And 95, 99% of the things we want to do on our layouts are incredibly simple. So
yeah, and that's where this kind of stuff comes in because it makes it so much easier to do. That way it saves you a ton of money. Now, obviously, this is not going to be the thing for somebody who doesn't understand electronics very well, not very friendly with a soldering iron, but I think a fair amount of us are, and some people just, just like with learning anything, maybe you're afraid to learn because you think it's too hard. But it's really not that hard. It's not like, especially like...
I don't think it's harder than buying. I don't think it's significantly anyway. I don't think it's significantly harder than going and buying a Circuitron or Tomair or NJ International or whoever crossing flasher circuit and
Yeah.
putting it together and understanding what goes where, doing it with the PICAXE is minor, if that, more difficult.
Yeah. So let me do something here.
And I'm fascinated by the idea that you could do reasonably high quality sound with this thing. But the Pro players and stuff, those are great. They're great devices, no question. But you're going to drop some money on those. And these that module's $5. This module here, it's $7 or $8 US dollars.
Yeah.
Put an SD card in it with an MP3 player of a sawmill or a loadout or a couple loadout.
And this thing's great because it gives you the ability to control it right from your PICAXE board. So you could have this plug in with your simple circuit for grade crossing flasher, and boom, you're done for like $8 instead of $40. So
it's small and a cheap little thing it's just it's cheap. And especially for certain people, for people building modular layouts or dioramas, run the thing off a battery or whatever. It could bonehead simple.
Yep, absolutely. Well, let's show you what this is. This here is what the Blockly version of the PICAXE programmer looks like. So it starts a brand new circuit right here, okay? So let's go return output on. Okay, see this going? Next, just like that. Then you go over to simulation and go run. See, there we go. It turned on that output briefly. It'll be 0. So you can now select, let's change that to be 3. Run. There you go. Turned it on briefly.
And I love that you get such instant gratification from it. Plug a couple of LEDs up, turn something on, it turns the light on. Immediately, you can figure out. Don't write 100 lines of code and figure out you don't know what the heck you're doing.
Right.
You can test it every step of the way.
So let's do this. Now we're going to turn on V3 for 1,000 milliseconds, just 1 second. And we're going to turn V4 on and pulse it for 500 milliseconds. Yeah. You know what? We'll just do this. This is what I forgot to do. Let's move this out of the way. This here is basically a loop command. So I take this, that's it like that. Boom. It turns that on, then it pulses back and forth. It just keeps repeating. There's a lot of simple ways you can do stuff like this. You just gotta go in and study what all these commands do. You can pause something, you can make it go to sleep, you can wait so many seconds, and just, think out the logic and drag and drop these modules in. And one thing I wish this had in it was if you could do this and see what the code does. Because then you get to learn it, And here's your different loops.
You wish you could say that one more time. You wish you could do what?
Well, do this and then see the code.
Oh yeah, going from block to code, that's driving me a little crazy too. Is that you kind of have to commit to one way or the other. And while I'm comfortable with code, what I've been playing with here lately since you started talking about doing this show, I've been playing with it. And even though I like writing code, the block designer works so doggone well that I have a hard time doing it the hard way. It's just
yeah. I mean, if you compare this to that, I mean, it's really not too bad. Now you see what here, right here it says toggle LED 1. So LED 1 is set as what they call a symbol here. The symbol defines what LED 1 means. So in this case, it's output B2, which is pin 11 on the chip. The apostrophe here makes this a comment. So now my LED 1 is on B2 of the diagram, which is pin 11. LED 2 is on the B4 of the diagram, and that is equivalent to P9, or pin 9. And then this here is just text entry, which will show up in the little programming window.
Which for the vast majority of people, you'll never have to learn the code. For guys who really are trying to do something complicated, you can. You don't have to, but you can get down to the code. Split Rock asked a question about powering the output of the LEDs. Is what range of LEDs will these control, and what power is needed?
Well, this board, like I said, runs between 3 to 5 volts. The outputs are regulated to drive the LEDs directly. There's a bank of resistors on there on the board. So when you build a circuit, you have to put a resistor in for the LED to lower it from 5 volts down to 3 for the LED, or if you power, say, 3 volts, you can drive the LEDs directly.
So if you're only powering LEDs, then you can power the PICAXE with 3 volts, just plug up 3-volt LEDs, and you don't need additional resistors or any of that jazz.
Yep. And same convert, you can power it with a 9-volt battery, and there's a 78-5 regulator on the board.
Boy, that's incredibly convenient, because with the Arduino, I've been messing with it to control signals, making that accessory decoder like you were talking about.
Yeah.
And you have to use resistors for, on everything. There's none of it. Can you just plug the LEDs up?
Yeah, so if you look right here on the board, right next to the header here, these are all resistors. And this chip regulates the output of 5 volts of power. Maybe can you turn your speakers down a little bit later here, echoing back?
Oh, I'll fix that.
Okay. So it's very simple. Like I said, I have a little 5-volt wall wart plugged in over there. But if you have a bunch of these, you hook up a tiny 5-volt wall transformer, and then just run 2 wires around your layout to connect all your flashers or whatever to. And it doesn't take these don't take much current, so it would, power a whole lot of them. Let's see what we got. Okay. Well, split rock, these will drive pretty much any standard LED, so you could use like a little 0402 surface mount. These connectors here are just a standard T3 LED, nothing major. Most LEDs run 20 to 25 milliamps with 3 volts. Red is a little bit more voltage, but it'll work pretty much anything. It depends on what resistor you design into the circuit. Like I said, this whole board here, you can build yourself just to drive the particular thing you need. So if you only need 2 flashers, I don't need this chip. I can use one of these little ones here, but then it's just enough output to do that. And each version of the chip has different outputs. So let's go back into the program there.
And on the PICAXE.com, I found a list, an index rather, that says how many outputs each has, how much internal memory it has. So if you need something that has a complex set of blocks that's going to do a whole lot of complicated things, like a signal processor, then you would need the more memory, but maybe not the more outputs.
Yeah.
So
let's go here to 08M2. Now you see here, it's about output these here, C1 through C5, so it's 6 pins that we can control, whereas we were using a 14M2, which has B0 through 5, which is 6, and C0 through 5, which is 12 total. So it's got a lot more outputs that you can utilize. This proto board over here only has hookup for 6 of the circuits. Now, I'm not positive the C side here may be the inputs and these may be the outputs. I'm not totally that familiar with all this yet. I'm still in my learning stage with this. But I will be doing a clinic with Mike on these in Amherst coming in January. So if anybody's interested in come in and get an hour, maybe we might, I don't know if we're going to be doing it hands-on yet or not. so we'll find out. But if we do hands-on, it's a matter of installing the software, which we'll provide, and plugging the programmer in. We'll have to see if we can get our hands on the components and everything for a live hands-on class. If not, we'll give a much more detailed presentation on things we can do with to come up with a few projects to demonstrate and everything.
The only difference that I've found between the C and the B's, other than the naming nomenclature, is that it looks like to me, from my research, again, I'm early on this too, is that the C's support pulse width modulation, so you could fade up, fade down, versus the B's only allow binary and like I2C bus input.
Oh, okay, gotcha.
That's what it looks like.
I got to learn some more about that, so.
Well, there's plenty to this jazz, and I don't think it's necessary for anybody to like wrap their head around all those capabilities if all you want to do is turn some lights on and off.
Yeah, I mean, if we're doing simple stuff like this, I mean, part of my whole goal is to show someone here how simple it is to do your own grade crossing circuits.
Yeah. And I'm interested in building lighting. As my big fascination is, it's a dirt cheap way to throw. I got a bunch of windows in this building, and I want to put little blocks in there and light them up at different times. Yeah. So it's real easy to throw. An Arduino is pretty hard to shove up in the base of this building, but that PICAXE will fit no problem, and it's simple to hook it up.
Yeah, you could mount it to the back wall, put a little cardboard box around it, you'd never see it.
Yep, I'm going to shove it right up in the bottom of this thing. It'll fit. And then also, the Arduino DCC++ system has an I2C out. Also, the PICAXE has I2C. So I could have this thing tell the building lighting the fast clock time. So at a certain time, it could fire away instead of variable. It's 1 o'clock, it's 2 o'clock, it's 3 o'clock. The lighting could coalesce around it. And while that seems fairly complicated, the actual act of dragging those blocks around seems to be trivial.
Well, it is. The thing is, once you understand what each of those blocks does, then it's a matter of what order do I put them in, and how do I, what sequence, not so much the order, but sometimes you'll have a group of them, and then you can define that group, say, as a symbol, and use that as a building block in other parts of your circuit. That's the whole idea behind defining a symbol is X, Y, or Z, because then you can just, in the code, say, turn LED 1 on. If it's LED 1, you've defined as this pin on the chip. So turn it on. Apply pulse width modulation for so many microseconds, etc. Drive this motor in this direction for so many seconds. So you can do it with animation.
So driving a motor or a servo, have you looked into that much? What about using it as a controller for a turnout servo?
Well, you can. This does support pulse width modulation, so you can.
Right.
I don't know how you would set your endpoints, but I imagine you would do it programmatically. So you'd say drive it for so many microseconds this way, drive it so many microseconds that way, and you would have to tweak it to get it where you want to work. But don't quote me on that. I'm not positive in that, but I know you can do it.
Gosh, that'd be trivially easy. And the servo's as small as it is, you're only adding a 1/4 inch to the length of a servo, and all of the circuitry's there.
I know. This board here, literally what you would need would be probably something about that big for all the parts you would need to do it. Yeah. If you have a regulated power supply, you don't need to build the power regulation on your own board. You just typically need, there's a couple resistors you need, or a resistor you need to trigger the serial input to make it run, and then parts you need to control your output. Split Rock here, he says, I might have missed this part earlier, but this is software you are using. The program is downloadable for free or slight cost from the manufacturer. The one I'm using, Split Rock, is, like I said, PICAXE Editor. It's from SparkFun, and it's free. You can get the Blockly one I was just showing, or the standard one. Now, the one I showed you with the Blockly has both, so I can either code or use the Blockly interface to do the programmatic blocks. So, but it's free. I mean, the only thing you'd have to pay for to program it, other than the chip, is the electronics needed to build the circuit and one-time purchase of one of these programmer boards. So,
and this application that I'm playing with is just a Chrome extension. So I'm using it on a Mac right now. I can use it on my Linux computers or Windows computer.
oh
It's
yeah,
just a
that's
Chrome
right.
extension, so nothing to install. It talks to the hardware via USB interface. You don't have to
Okay.
install anything. It just works. It essentially does the same thing. Of course, it does support programming into PICAXE Basic, but also for people who have website experience, you can write in JavaScript or pass XML data. I mean, that's getting kind of deep, but it has everything that I can find from the other one, and it's in a Chrome extension for free.
So
That
it's
you don't
plugged
even
right
have
in your
to.
browser.
Yeah, you don't have to install it. It just turn it on in your browser and launch it. It launches as an independent window that I've got in full screen, and Bob's your
That's
uncle.
really nice. I'll have to check that out. Because that way, you can just open a few tabs and just copy and paste code back and forth.
Well, of course, I mean, I like the flexibility. I mean, I've got Windows computers around too, because there are things that require Windows, but it's just, I'm using a Mac right here, and I've encouraged a lot of people to consider taking their old Windows XP computer or whatever, throwing a free copy of Linux on it, and using it as a dedicated JMRI system.
Yeah, I mean, that's very popular for people to do that. And then you can install Chrome on it and load this in, or it has PICAXE programming software has a native Linux version too. So, and you can use a much less powerful computer to do all this kind of work with running Linux. Now, Squint Rock, you asked here, would this drive the LED light packages offered by Woodland Scenics or the MRC Light Genie? Well, it all depends upon the lights. I think they're all LED, but you have to see if they're designed, like if the ones from Woodland Scenics, if they're designed to plug into their board, how many volts does their circuit give you? If it gives you 12 volts and there's a resistor in the light to dumb it down, yeah, you might not be able to use that directly with this. I don't know if this will do a 12-volt output to feed.
No, they have a separate board that allows you to get to control higher powered outputs, like a motor control shield for an Arduino does, where it just triggers it, and then you pass it 12 volts or however many amps. However, using the Woodland Scenics system would be somewhat redundant because this board does pulse width modulation, and the value of the Woodland Scenics controller is that it also does pulse width. So you're kind of doing the same job. One of those, the Woodland Scenics, is meant to use a little knob that you twist, whereas this can be programmatically actuated.
So that's what that knob in the Woodland Scenics one does. Then.
Well, that knob on Woodland Scenics is meant to control the brightness, which with an LED is not simply turning more voltage up or down. What an LED does, so with a light bulb, if you give it 3 volts, it's dim. You give it 7 or 8 volts, it's brighter. That's simple to understand that. But with an LED, you've got to give it 1.5 or 3 volts all the time. So if you want it to be dimmer, what you do is flash it so fast that the human eye can't see it. And if you want it to be dimmer, you flash it less often. You want it to be brighter, you flash it more often. And the human eye interprets that as brighter. So it's a trick. It's optical illusion of sorts.
That's what they mean by pulse width modulation. Basically, every so many seconds, you pulse it. So the wider the width of the pulse, say you have a 1 second pulse that's this wide.
Yep.
Well, if I pulse it once a second, it's going to look like it's on steady state, always lit. If I cut it half, now it's only on for half of that 1 second. It's going to look like it's dimmer. 1 second is a number.
That's right.
But they do it fast enough so it appears dimmer because your eye is fooled by it's on, off, on, off, on, off, on, off. It thinks it's dimmer, but it's not.
Well, the human eye can't see you switching something 60 times a second or 100, 300 times a second, but that's the trick of the electronics to get where we need to with digital stuff that doesn't work like analog. And this system, the PICAXE, does all of that same capability, dimming a light bulb. So you with the PICAXE, you could use the pulse width modulation output in that block link to say, turn this on, pulse it every 200 milliseconds or however often you want, and it would be dimmer. And what's beautiful is you plug this thing up, set it to 200 milliseconds. If it's not bright enough, turn it to 100 milliseconds, and it'll get brighter.
Yep, that's all there is to it. It's relatively simple when you start looking at it, you know.
Yep.
I mean, obviously, we're all tech guys in here. We say it's simple, but to someone with from basic electronics, it doesn't sound so simple.
It doesn't sound it, but I promise, if you could install a Digitrax signal system or any of that other stuff, you could do this too. This is no more difficult than installing a commercial product. Not because the product is easier, but because the community behind it has already done all the hard work.
Yeah, I mean, there's so much code available for these things that do different things, even pieces of code. And then really, you know, if I need this capability, like I need to flash it for so many seconds and turn it off and activate another LED out or another output, then go back to this. There's code out there for it. And then you just got to string those bits and pieces together and make some sense out of it. And that's where the Blockly thing comes in great, because you can snap all your blocks together, simulate it. If it doesn't do what you want, keep trying, you know.
And copy and paste bits and pieces. If you've seen something that does the flasher that simulates, you know, a welding circuit, because I want to recreate the kind of flashing effect that happens when a TV is on in a room. So
yeah, I mean,
take that part of the circuit.
Yep.
Just copy that bit, and with the block, you know, copy that bit of the thing, paste it in there, and you don't have to be a programmer to copy paste.
No, you're right. That's what makes it so simple.
I mean, you see all kinds of people on the internet, not just motor railroaders, of course, all kinds of guys who are not programmers, who do not know how to program, but are doing fairly advanced stuff, controlling garage doors with their phones by buying an Arduino and hooking it up. These guys didn't go spend a month learning how to program. They downloaded some stuff, they copied and pasted, they watched 3 YouTube videos, and they soldered a dozen wires, they were done. It's not, you know, nothing that an afternoon of YouTube can't teach you.
Exactly. It's, I mean, there's so many resources to learn this stuff.
And I get the natural fear, you know, the tendency for people to be afraid of some of these things, but I assure you, if you can hook up a DCC system other than just plugging it into the tracks, if you could solder some switches and control some turnouts and do some of that advanced, you know, those advanced things out there. I mean, Troy, I've watched him build his layout, put all that electronics in there, and months ago he would have said, I'm not an electronics guy, blah, blah, blah. He's built, you know, his layout that he showed off on Saturday. Look at all that electronics under there, and it's all from, it's not that it's hard, it just takes the effort of going and doing it and not being afraid of it. This fits into that same explanation.
I want to try something. I don't know if it's going to work or not, but let's see. Let's stop this. Okay, I'm going to share my screen here. So here's a part of the Lighthouse code that I downloaded. So what I want to do now is...
Did you just copy this from somebody else, or did you have to write that?
No, this was from that TrainElectronics.com. I mean, Dave Bodner even has built a mini DCC controller using these things. So.
Well, he's the guy. Dave Bodner is the guy that I got this stuff from. Is watching his videos. So anybody that's at least been interested should be following him.
Yeah, TrainElectronics.com. There's a wealth of resources.
Yeah, man.
Yep. Let me see how this works here. See what's working here. All right. Yeah, right now this has got the light on solid state, so that's not really working to do what I want to do. I gotta debug this a little bit.
Well, the guys who wrote this thing must have had a sense of humor. Everything's like loopies and I mean, I get
Yeah,
there's some British English, and actually that was something that Dwight mentioned a minute ago. If he could get it in regular English instead of British, but it's
yeah,
obviously British.
yeah. So, let me go back and copy this part right here. See, this is what I'm missing.
Oh, I understand what that is. That's just a variable somebody's defined as loopy.
Yeah, yeah. All right, let's run this. Right here. Let's see, it's not actually running this. The second part of the code, so there's something we're missing in this presentation. So, yeah, see here, it should be used pulse width modulation to brighten it, and then flash to full bright, and repeat backwards again. So, this I got to look at why this is not working. But essentially, like I said earlier, it should use the pulse width modulation to light the LED dim and brighten it up briefly, then back down again to simulate the rotating beacon. And think about it. You could build a tiny circle like this and put it in your locomotive to use it as a beacon on the roof. You know, like in a DC locomotive or a large-scale locomotive or something. So,
Actually, I don't know that would be impossible. As small as this PICAXE is,
no, you're right. It wouldn't be. It wouldn't be.
I mean, you could shove this in the cab of a Jeep 60 or something and put that, or or an SD40 or something, and stick that strobe up there.
No, I totally agree with you there, Andy. That would definitely work. See,
But
we'll
the
get
idea of being able to control a speaker, that I found that a couple days ago, and I was thinking about this from a input-output perspective, but the ability to learn the capabilities and to be able to stick sound on it as well, because I'm going to I'm interested in the servo control, the signal control aspects, obviously, but I want to put a speaker under my turnouts because if you've stood beside, if you've been out rail fanning and you've heard that machine throw a turnout, there's some sound there, and I want to capture that sound effect, put a little speaker. I mean, I got a servo there, I got a controller there. What's it cost to stick a speaker there too? And with the and as you're operating the layout, there's a lot better feedback when you hear click as it unlocks and as that thing grinds the points in the other position. So, and that cost you $5.
yeah. So, Split Rock, you're asking about the cost. It's a basic kit. So, let me pull this out to a separate window. That way I can share it. So this is on SparkFun. So here we have the serial interface programming cable. It's $20 for that cable with a little audio connector that plugs into the programmer. Like I said, you don't need to do that. There's a diagrams available in Train Electronics shows you how to take a 3-wire servo connector and solder them onto the programmer to bypass this cable. Now here you have a prototype board kit, which is battery operated. It's very simple, $4. And you buy a $5 chip, which is the 18M2, which you can get these two. You can see the 08M2 is $2.95. The one we were using tonight, the 14M2, is $4. So it's not expensive. The serial cables, this is for actual computer with serial port. But if you get the little header and solder on the program board, you don't even need that. You just use a regular mini USB type A cable. So there's some very simple stuff here. This is all, let's see.
And PICAXE.com has a few of these starter packs that I've been looking at. This experimenter that has the breadboard, programmer, got a battery pack, but who cares? That's like €45, so whatever, 50-some dollars.
Yeah, it's slowing down a bit. Not too much stuff running at one time. But yeah, just check out on SparkFun here, and you'll be able to find out. You know, here's your chips, the different ones they sell. So let's see. All right, there's the program. Oops. Yeah, we're back to this here. So let's take a look at this one. It's a very basic beginner's kit for kit for the 8-pin PICAXE, which is like your 08 M2. Includes a handful of easy to solder to through-hole components, and you have to buy the chip separately. And this thing works anywhere. Battery snaps provided, but the board must only be driven with a 4.5 to 5 volt battery pack. To prevent the 9 volt from accidentally being attached to the 5 volt board, we recommend attaching a 3 AA battery pack below. That would, let's see.
Does that one have a breadboard on it?
Yeah, this is a basic breadboard. That's like that.
Oh, yeah.
Yeah, so let's see here.
That's enough. I mean, that's what people need, is to be able to shove a couple of LEDs in there, flip a few switches, and gain some confidence.
Yeah, like I said, this whole setup here minus the chip is $4. You can use this to build circuits for your crossing. You know, you buy $3 for one of these chips, $4 for us, now you're up to $7. And you buy one programmer and just keep programming your boards. This one here, you would use that $20 cable. You buy one of them, plug it in right there, and then it works great. I mean, I actually bring my camera back. Yeah, this is that board right here. So I would just use program, and I just need one of these cables here. Like this. You plug in a USB in your computer, plug it in, you're ready to program. Chip goes in the socket, you got your power connections right here. Then you can connect whatever else you need out on here for your LEDs and such. And it's all, each row, what it looks like, there's groups of pins here on the back that are tied to each one of these pins. You'd have to look at how the circuit traces go. But nice and simple, like dirt cheap. So you can make yourself, like I said, why pay $40 for Circuitron, you know?
When you're only paying that amount of money to get basically set up with the programmer stuff one time, for each program, for each chip that you buy, that's a couple bucks, $5 or something, and you can solder the LEDs and the wiring to your building. So while you're buying that programmer to get you started and to set up your station for doing this work, to light up a building, it's going to cost you $5 plus the cost of some LEDs.
Yeah. So I mean, I myself will probably go this route just because it'll save you money. I enjoy doing this stuff. It'll be fun to learn it, and save yourself a boatload of money. You know. And then I can
some of these things that you can't do. You know, there's some of these things that you can't take an accessory decoder, even though that's $40 or $50 necessarily, and use it to control a bunch of lights in a building easily. That's a very hard engineering project to do. So, I mean, the PICAXE, not only is it cheap and fairly easy, but it fulfills kind of a niche that's pretty doggone hard to do otherwise.
Yeah, and you're absolutely right. Okay, so Split Rock says the number of pins determine the number of outputs or functions. Yeah, each chip has a different number of pins, but it's all got the same, like +5, -5, or a 0, and then a serial input pin. All the other pins are functions. Some of them can be used with pulse width, some can't. But it's still, you can all use them for LEDs or something like that. So each chip, you'd have to look at the actual chip itself. See what Andy's got here. So yeah, so here's some starter packs. Now, here's your pinout. You see the ones over here on the left have pulse width modulation, but not all of them over here do. Some of the inputs and outputs have different controls.
And they have, there's this list here on the PICAXE.com that has these, that has this chart. So you have the memory capacity for how much storage you could put on there. How complex of a program are you writing? Right. And then you get into, and then there's some of these things like parallel tasks. So some of these that have like, a whole lot of input and outputs, like the 40x2 or whatever, it can do one thing at a time, and that's it. So if you're trying to do like a signal controller, then you probably need to look at one of these like, the 20M2 that can do multiple things at once.
Yeah, so, plus you can see it has more memory. So.
Yeah, I'm still torn by, exactly how the right way to do this because of this I2C. Because if you wanted to do a signal system like you were talking about, you probably would have used I2C to talk, which means you're going to be using one of these three. So,
so what is the I2C?
So I2C is a communication protocol for small electronics. Arduinos can do it. A Raspberry Pi can do it. PICAXE and various other controllers can do it. It's 2 wires. Pretty sure it's 2 wires. It's a signal wire, got to give it some power. So it's a clock and a signal. So there's 2 wires. They can be low voltage. So you could take a piece of telephone wire, run it around your whole layout, hook a very small bit of electronics at each turnout, and each building, for example, in my case, I'm just going to run a little piece of telephone wire around between the buildings and use that to pass the control bus to it. And it's I2C. And then with the integration, you've got, that's what I was playing with this I2C. You could just say, read this variable. So you say, with this variable sets to this, then do this stuff right here.
Right.
Now that gets a little more advanced, and I could see the necessity to, if people were interested in doing a whole show dedicated to how to use I2C on your model railroad, but it would allow you to not have to put an Arduino or a PICAXE at one place and run upteen million wires back to it. You could just put one of these little chips in every building and run 2 wires to all of them. So.
And have a central one that would drive the inputs.
Yeah, and I favor distribution, distributed. I want to put all the electronics right out close to the turnouts and right out close to the signals on my layout. So.
Okay. Is there anything else you can think of covering, Andy? I mean, at least for tonight. I mean, I didn't want to go too far into this because, this is something that, I maybe would want to devote some more time to in the future. So.
Oh, yeah, and I haven't even got a hold of the hardware. All I've done is you wanted to talk about it, so I started reading and, have some ideas about it. I'm going to get my hands on the hardware, and I'm convinced that this is the right way to economically control building lighting, to give... I think that's one way to give life to a layout. In a way, I think our layouts look like dioramas, except for the fact that trains move by, and I want more life.
Right. Now, like you said, if you can get like a fast clock signal into it, etc., then it would definitely be perfect. But even if you just say, if I know I'm going to just want to turn random building lights on and off, you wouldn't even need that. You wouldn't need to use the I2C. You just want to turn this one on. There's ways to do random number generation. So you turn this one on for random number of seconds, that one on for random number of seconds. And when you put all these boards in your buildings, they all do different things by themselves.
Yeah, so when you turn the layout on, all these things boot up, and one light comes on for 20 minutes, and then a few minutes later, another one comes on for 30 minutes, 10 minutes later, this other one goes off, and that's really simple, and I've seen it in action. At the NMRA National, there was a guy who had some modules, and he was taking the Arduino Nanos, the very small form factor, about the size of a stick of chewing gum, but they're $10 or $12, and they're more complicated to program. But he had put them in all of his buildings, and they did this little random sequence of things that were happening, and it's fascinating, and it brings the layout to life in a cost-effective way.
Yeah, and it's like, if you really want to control, so when you go into nighttime mode on your layout, and your lights go to a certain sequence, and you're running on a fixed fast clock, you probably need to use something more like an Arduino, something that's more programmable. But you can do that with PIC chips. If you're into programming with something like C, where it has more capability. Because then you can introduce some randomosity that you may not be able to do with this, because you would need more functions. Like maybe one of the bigger chips with the 8 functions, at a time, you could do that. So you could set timers and variables and such. So it might be possible with these. I'd have to do some experimenting with it. So.
Well, I'm sure it's possible to an extent. So here's my simple thinking on it, is to take an Arduino and make it the master. Make it the controller. It is in charge of everything. Actually, I'm just going to do it right on the DCC system, because there's plenty of processing power left on this thing after it controls a bunch of locomotives. So I'm going to take this. It's the master. It knows what everything else has to do on what sequence. And then I put a PICAXE in the bottom of every building, and I run 2 wires to it. And this tells that building to take whatever action, and the PICAXE determines what lights have to be turned on to satisfy that requirement. So separating it makes it easier for me to wrap my head around and do one part at a time, and not make it so complicated. It sounds complicated, but it's easier.
So you could say set a variable, and then it would send that variable out over the wire, and then the PICAXE will say, oh, I see that variable. If it's this value, do something.
Yep. So what you do is with the in block controlling the PICAXE, you say when variable this is 1, then whatever. Then all the Arduino has to do is set those variables, and every building on your layout takes action. So when I want to add a new building to my layout or wire a new building, I don't have to do anything in the Arduino. All I have to do is program the PICAXE to take actions based on variables and plug it up to I2C.
Yeah, and then to make it random, when you program, instead of responding to the same variable and doing the same thing with every building at the same time, put a random number generator. So if variable X becomes 1, use a random number to time out how long the light waits till it goes on and how long it stays on, and then just keep randomly doing that until the variable changes from 1 to 0 when the light goes off. So that random factor then makes every building unique with a piece of software instead of hardware, or a lot of the fancy programming on the Arduino side to control each individual building. Make the PICAXE chip do it.
Yeah, I want a random element, too, of course. I mean, you kind of destroy the illusion when every bedroom in every house in your small town comes on at the same time. You've destroyed the illusion. Not to mention, I don't want it to be repeatable. So when I run trains tonight and tomorrow night and the next night and the next night, I don't want the same actions, you know? Johnny don't get up for work every morning at exactly the same time. So...
yeah, this is true. And that's exactly what you want to do. You want to throw that random element in there.
Yep.
So. And if that can be achieved, which I think it can, I mean, Mike did with the PIC chip, but it uses some of the same languages. So you may just need to program these things with a little more advanced language, or go from PICAXE to PIC, and then it's the same basic function, just you need the ability to throw in a random value that you can control. When those variables say do this, well, let's wait a random amount of time before we do that. Then stay on for a variable amount of time, then go off.
Well, you got to use the right tool for the right job. So the PIC boards, like what Mike used, if you're wiring the electronics to control a fuel refinery or a coal prep plant or some big facility with a lot of lights, you're going to need a little more than a PICAXE could probably do because the sheer number of outputs is going to be a limitation.
Yeah.
But
So
for,
he was redesigning that whole thing to use a command bus like the I2C. I don't think that's what he had chose, but
yeah,
he
there's a
chose.
couple of those. A couple of those buses, and actually LCC, which has got all kinds of attention, and I've mentioned it a few times because I kind of fell in love with that protocol. Speaking of which, you could make an Arduino speak I2C as well, or make an Arduino speak LCC as well. But
Yeah.
that's using the CAN bus, so it's not far removed from I2C. You could also
Mhm.
use the I2C bus, for example, to take a PICAXE that only has 20 outputs, and take I2C and go about a quarter inch and put a little multiplexer on there and put 100 things on there. So you could
Oh.
take a PICAXE and control 100 different lines.
Oh wow, interesting. Well, that's something to maybe down the road start researching. This is a project that we can present. So tonight's goal was to present the product, discuss what you need to program it, wire it up, and then show a simple project like the grade crossing flasher. And then, obviously I didn't get into showing the trigger inputs, but because the pins can be used for input and or output, you would just put a trigger like a photo cell into your input. The photo cell goes dark and it generates 5 volts through it. Oh, okay, pin 1 with 5 volts, start the flasher. And then
Yep.
when that goes light again, turn it off. Then you can add a second trigger and just write it. If this one goes high, start the circuit, shut it off when this one goes high then low, and then, and there's ways to do multiples so you can have bi-directional. So it's pretty simple and straightforward logic. You just have to think the logic out in your head and then either write the code or use Blockly to put the modules in and just control the path that the statement's flowing. So,
Well, the Blockly kind of lets you program it directly out of your mind. It's like a
yeah,
workspace, It's like a little
yeah,
sandbox that
it's
you can
basically
play
like a
in.
workflow program.
Yeah, and you get
So
real world effects. Drag the blocks, plug the LEDs up, drag the blocks around, click run. If it's not
yeah,
the effect you like, drag the blocks around a little more.
yeah, that's exactly it. That's why I wish in the end they would let you see the code behind that.
I know, right?
Well, you know what though? Let me see. There might be a way. Hang on.
When I had thought about saving the project, I haven't done enough of this yet, but I thought about saving the project and then reopening it in the code. But I haven't got around
Well,
to playing with the various ways of doing that. And there's a lot more that
it.
can be done with this, and I think there's several good shows left in this
Oh yeah.
product.
Now,
I mean, the goal here I
Lockley
know
is
was just
actually.
to get people excited about it, and maybe
Yeah.
talk them into spending some money like we're good at around here. But
Yeah. Well, the Blockly here, see, looks like it saves in an XML format. So you can open XML, I believe, in. Let's see if we can open up the XML.
yeah, I mean, you can open it in Notepad if you really wanted to get that hardcore about it. You can. You don't
Yeah,
have to.
yeah. So yeah, you can definitely, edit the Blockly file after the fact if you can't quite do what you wanted to do. You'd have to learn how XML controls it. But apparently what it'll probably do is take the XML and parse real code, the basic code out to the chip.
Actually, it
So
does in the Chrome. I've been playing with the desktop app on a Windows computer at the office because that's what I thought I needed to do. But for this,
right.
I installed the Chrome. Here, if you look at so let's take this apart. If you look at PICAXE Basic, you see there's nothing in there. There's no
Right.
actions taking place.
Right.
You go take this code, drop it in there. Now it has the code. So it is real time showing you the code.
Oh,
But I did not
I
get
like
that
that.
on the desktop version. But
No, it's not in the desktop version, not that I can see. Oh, look, you can click back and forth at the top, blocks and code.
yeah, but it lets you manipulate it, in real time. We can break that apart and then look at the effects of it. Look at
Oh,
this pin when this variable's red, then stop, then add back, a part of this. And that way you can get an idea of if that pin, goes 1, then take pin C and make it high. So
yeah. That's pretty sweet. Mike had showed me the Blockly over the weekend. It's like, yeah, I got to play with this. So.
Yeah, I'm kind of fast. Like I said, I'm comfortable programming. I got, no
Oh,
problem
you do
programming.
that for a living, yeah.
But this is just so good that why do it the hard way, even if you can?
Oh, yeah. I mean, and they've attempted, different people have attempted to make environments like this for young kids to learn how to program. But like in here, you need to have this view plus the code view. That's why, like when I edit web pages, I use Adobe Dreamweaver, and I check the code to see what I'm doing, what it's causing. Sometimes you can make a pretty graphic picture, and it's got some ugly code, and it doesn't need to be that way.
God,
So
Dreamweaver makes such dirty code, though. It just drives me crazy.
not as bad as front page used to or Microsoft
Oh,
Word.
God. Oh, front page was the worst.
I don't know. Microsoft Word's kind of just about the same engine, I think.
But this is nice because it shows you. So I'm using the 20M2 as an example because I think that's the one I want to order to play with. And when you execute
Okay.
the code, you can watch this pin C0 go high here in a minute. Yeah, I mean, when you get it to a
Right.
certain point, you can watch, so you can see what's going to happen. No, you can't
Right.
in the simulator tie LEDs to it, but
Yeah, but as long as you can see it.
yeah, you get an idea. It's got some really interesting server control stuff. I don't
Yeah.
understand it yet.
Yeah, but I mean, this is something like you said. We have some future shows we can do here, so I think in the end we'll have some definite good stuff to work on. Because coming up in the end of the year, we're going to touch on the Arduino that Andy likes to talk about.
I'm fascinated with Arduinos.
Yeah.
I've got a dozen in the house. I've got one hooked to my doorbell, so it sends me a text message.
Oh well.
I mean, I didn't write it. I just stole it off the internet. Unapologetically stole that code off the internet. So
Yeah.
it's
That's what people publish it for. So.
sure it's easy to do, but there's so many things you could take with this PICAXE and create some more shows about. I mean, you could do a whole show around the ability to hook a speaker to this doggone thing.
Yeah, I mean, like I said, we can occasionally do a pickaxe thing on a project like that. Like, maybe we'll work on doing building lighting like we talked about.
And
Then,
layout sound is a bit of a fascination of mine too. Of course, I want the layout to feel alive, and sound is one of the best ways to do that. And you can go buy the PriCom boards, and they're great. No argument at all. They're great boards. But if you really get into that, you're going to spend some money. You're going to spend quite a bit of money.
well,
If you can do this,
if you go to, I think it's Microluminaria. I know the guy that owns it. He sells these little that are about half the size of one of these proto boards.
yeah,
And they come with a little speaker attached to them, and they're preloaded with sounds, and he can put whatever sound you want to them. And Mike got the information from him how to trigger them with a decoder, so you probably could trigger them with one of these chips too. And they're like cheap; they're like $15 to $20 a piece.
what side is that?
I think it's Microluminaria.
Oh, okay. I've seen them because he sells LEDs as well, like pre-wired LEDs.
Yeah.
But there's a company called Engineering, spelled with the, just the letter E.
Yeah, well, they make a lot of stuff for Microluminaria.
The problem that I've had with all of them I've seen so far is the low bit rate. Like PriCom, yes, they're expensive, but they're good CD quality audio. So if you had
Yeah, well, that is one difference.
yeah, and for some things that doesn't matter. For very low frequency sounds or for some birds chirping, that's not totally necessary. But if you want to catch the roar of a river rushing by, which is important to me, I have a scene where I want that sound effect. Then I want pretty decent audio.
Oh, sure, because you don't want it to sound just like
No, I'm not.
you want it to be
Can't
crystal
be
clear.
It's just not that hard to do it well. And PriCom is great, very high quality, very good sound. They have the PriCom network, so you can hook all these things together so they can correlate and have interactivity and tie to your central lighting system done by PriCom, which I priced out for my layout. It was going to be like $1,500. So I decided to build my own lighting system. So it, as the lights come up through the day and down at night, but I want those birds chirping in the morning and crickets at night, and
Yeah.
that. And again, if that was really hard or really expensive, I probably wouldn't do it. But it's
Yeah.
relatively easy and relatively inexpensive. And since it's easy and inexpensive, it's a great effect.
It's funny. I'm looking on their website. I don't see those soundboards listed here, and I know they sell them at shows.
I've looked. I've looked on their website because I meant to order some of those pre-wired Dado LEDs,
Yeah.
microluminary. I know I've looked here, and I know
Which,
engineer microlumin.com. I know that engineering sells that.
well, I think they make them for microlumina. So another place to check for cheap LEDs, if you buy them in bulk, would be Evans Lighting. I think it is. They're the ones that make the model builder software.
Really?
You could get pre-wired 0402 LEDs with red and green wire and a resistor all soldered in. For about, if you buy like a bulk of them, you can get it for like $1.14 a piece.
Oh yeah, these are the guys who do all that sci-fi lighting, Evans lighting. Yeah.
Yeah. And so you have to spend over so much money. Then they would do is they give you a 40% price discount.
Oh
But you
well,
get
and
it.
they have like that electroluminescent wire
Yeah.
that that little glass tube. It looks like fiber optic. That
Excuse me.
like in 1950, where I'm modeling, the world was totally fascinated by neon. So
Yeah.
I've kind of got to capture that effect, and you can buy those signs from. Uh, oh,
Miller Engineering.
yeah, and they're not bad.
Yeah.
They look pretty good, and they're
Yeah.
relatively expensive, but they add up. And if you want to do custom stuff, then you can buy that luminescent wire, and all you got to do is glue it to a piece of board in the shape of what you want. And you've got neon,
Yeah.
and it kind of, I think it looks better than the.
It's not even actually a like a glass tube. It's actually a wire coated with phosphor, and there's
Right.
like the center wire, then a conductive tube, and the coating on the outside. So when you charge the circuit, it makes it glow,
Yep.
literally like neon. And I think it's cool neon. You can get it down as small as like 1.2 millimeters. They call it their angel wire or something like that. So it's really thin. Because I'm considering using it to do signage and roof edge lighting. Because I bought the Mobius models, Mel's Drive-In from American Graffiti, and it's got neon tube everywhere. And I was figuring I could use that for the neon tube.
Well, there's a guy, Toy Train Man, I think is his name on YouTube. I mean, he models O scale narrow gauge. So he's not
Right.
Lionel or anything. He's a hardcore craftsman model railroader
Right.
who has a YouTube channel that's entirely interesting. But he did a side in O scale, and he captured he built the side off from a prototype, pulled the LED through using that electroluminescent wire, and he captured those miniature curves that happen where the neon comes out from the back of the side.
Oh,
And
yeah.
yeah, he captured that whole effect, and he even did damage to the wire so that he could create that effect of where neon gets spots in it, where
Yeah.
the neon goes black at spots because it gets old. He captured that effect with the electroluminescent wire. His video is worth watching on for interest in recreating neon that way.
Model train guy, you said?
It's a Toy Train Man, I
Oh,
think.
toy train guy. Okay. All right. I'll
Yeah,
check
and
him out.
again, he's not a Lionel guy. He sounds like it by his name, but he's
Yeah.
he's a craftsman modeler. I'll find it for you.
Yeah. Okay. You can just pop it in the chat. So I guess we're going to wind up here for the night, guys. I think we beat the horse to death as usual. So I hope everybody enjoyed. I mean, we had a fair amount of viewership hanging on, and some of the people really want to learn this crazy techie stuff we do. So like Andy said, we'll come up with some project ideas and maybe present, this is how to do this with a pickaxe. I really wanted this just to be the intro to everything to whet people's appetites. And then, Toy Train, Toy Man Television. Okay, cool. Thank you, sir. So, and then coming up at the end of the year, like I said, we're going to do a show Arduino, so we'll have Andy back with that and everything. That's his forte, man. So we'll use his expertise to the best of our abilities. All right, everybody. I hope you all have a good night. Just wanted to remind everybody to keep their eye out for YouTubeModelBuilders.com. Always check it there for all your free resources and everything else that we provide, the eMag and such. So make sure you check us out. And go subscribe, that way you'll get notified when the eMag comes out, and we send out emails about when the live show is going to be. So come join us. All right, everybody. Have a good night. And sorry Mikey couldn't hang out. He was having technical difficulties. Andy, as always, thank you. And we shall see you folks next time. Goodbye.
Good job.